Hello guys, this lesson is going to cover how to make an equation out of a transformed graph, and this is going to be in the grade 11 curriculum or grade 10 pre-IB math curriculum. Okay, first thing you guys have to know or keep in mind is this. This is called the general function notation, and it goes y equals af b x minus h plus k. I will go into these things more clearly later, but the basics is that this describes the vertical stretch and vertical reflection, and this describes the horizontal reflection, horizontal stretch, and these two I will discuss later. And f here, so f bracket basically just means it's either like in this whole bracket, right? So we just write it down. Fx can be rewritten as, for example, a parabola. You can say this just becomes x squared here. No, actually, like that. Or if you're working with the root, then it's going to be like this. Alright, and if you're working with a absolute value function, it's going to be like this. Okay, so that's what the f bracket means, right? You just replace it with whatever function you're working with, like for example the square root or the absolute value. Okay, so let's go on to how to actually make an equation. The first step is to determine the vertex. So the vertex basically applies for all the parent functions except for the reciprocal. I will talk about the reciprocal later, but yeah. So what the first step means is you identify where does a function start or where does it peak. So for an absolute value function, it obviously peaks here. That's your vertex. And for here, where it starts is here, where the function starts the curve, the root function. Okay, so we need the coordinates of the vertex to plug into x and h, to h and k. Okay, so for example, this one is going to be -2, 2. That means that this function notation here, it turns into y equals a root b x plus 2 minus 2. Plug in these as h and k, right? And then you obviously apply the root because f bracket, as said earlier, just replace the function in. This is a root function, by the way. Okay, so that's your first step. Your second step is you either assume a or b is 1, right? So you can't really solve for both a and b because you only have one equation. It's not a simultaneous equation, so you either choose a or b to solve for, right? So let's say I choose a. Okay, so you assume b is 1. Okay, so the first step to how to make an equation out of a transform graph is to find the vertex. And the vertex means either like a peak, like in a parabola, right? You have a peak down here, or like a peak up here, right? That's your vertex. For absolute value function, it's going to be right here, right, the peak, and then for a root function, it's going to be right here. Alright, it's going to be where it starts, where the function starts to curve, right? Okay, and you're going to replace the coordinates of the vertex into h and k. So for example, this one's going to be, let's try this one. 1, 2, 3, that's 3. 1, 2, 3, 4. It's gonna be 4. So your coordinates of this one's gonna be 3, -4. So you can plug it in here. This is an absolute value function. So absolute value here. Sorry. Okay, you plug it in as h and k. Okay, next step. Assume either a or it's gonna be b. Assume either a or b is 1. You cannot solve for both, right? Because now we have this. thing right here. You have a, b. What do you solve for? Because you don't have a simultaneous equation. You can't set up a linear system to solve this. So you have to either choose a or b as to 1, like set it to 1, so it cancels out. Okay, so in this case, I'll assume b is 1. So if b is 1, then it cancels out. Okay, all right. And then our last step is to take a clean point and then plug it into the equation to solve for b or a. So basically, just take any clean point and then plug it into x and y to solve for the a value. So this one is going to be 5, 0. So let's plug it in. So y is going to be 0 equals a. Absolute value x minus 3 minus 4. Rearrange that. So 2a. A equals 2. So we're going to get y equals 2 x minus 3 is 4. That's going to be your equation. Okay, that easy. It's that easy. Okay, but if you're not working with square root functions, do not if you're not working with square root functions, do not worry about reflections. If you are working with square root functions, vertical and horizontal reflections must be considered. So basically that means that you're still ignoring a or b, right? You're still either choosing one of them to ignore. But you have to recognize that, okay, the normal root function goes like this. But once you flip it, let's say this one flips to this one flips across the y-axis, because normally it goes this way, now it's going this way. So it's a horizontal flip across the y-axis. So you're gonna say that b has a negative in front of it, right? So yeah, so instead of just putting b as 1, you can either say b is negative 1 and then solve for a, or you can just solve for b in general. Okay, so that's just how it works, right? Because an explanation is that because a square root function, the domain of it, right? The domain of it is x er such that x is smaller than or equal to 0, right? There's a restriction, so that's why we have to consider the negative as well, right? Either an a or b. For example, if this graph were to go like this, then your a would be negative. Okay, so you only really consider the negative when you're working with square root functions, or else with normal functions like this one with a parabola, solving normally and ignoring b would give you a as negative or positive depending on whatever it is, right? So you just don't worry about the negative thing if you're working with these type of functions, except for the root function. Okay, so let's try some practice problems. First one, we identify the vertex, the peak, whatever you can call it. I'm going to choose to, again, solve for a, assume b is 0. It's really simple, it's just plugging in numbers. So it's going to be negative 2, a. That's your equation. Okay, and this is what I mean, right? You don't have to account for the reflection, because when you solve for a, it already gives you the negative here. So it already gives you the reflection. It already accounts for the reflection for graphs that are not the square root graph, right? Okay, now let's talk about reciprocal functions. Reciprocal functions have a different format of general function notation. Normally, it's going to go like this, right? X minus h plus k. But in a reciprocal function, it's going to be like this. A on the top, b x minus h plus k. And h is no longer a vertex. This is the vertical asymptote, because a reciprocal function doesn't really have a vertex. Okay, so that's going to be a vertical asymptote, and k is going to be the horizontal asymptote. Okay, and what an asymptote is, just for a reminder of the pairing function lesson, an asymptote is essentially a value, an x or y value, or x or y like line, horizontal or vertical line, that as the function approaches infinity, it's approaching that value as well. So let me just do an example here. Horizontal asymptote is going to be right here. Why? Because if you imagine the graph just extending forever, it's going to approach. It's not going to reach it, right? But it's going to eventually approach this line. Yeah, this horizontal line at y equals -2. That's your horizontal asymptote. You have to label this, right? Okay. Again, vertical asymptote, same thing. It's the line, the vertical line that as the function extends to infinity, it's approaching that value. So x equals 1 is your vertical asymptote. Okay, so what you do is just plug straight into h and k. So vertical asymptote, horizontal asymptote. There you go. Okay, now again, you choose A or B to set equals 1. So let me just choose B to set equals 1. Now let's solve for A. Let's pick a clean point. It gives you the point there, so I'm gonna choose 1.75 and 0. Okay. Okay. So 2 over here. So 0.75, which is 3 over 2. Okay. So that's going to be your A value. Plugging it back together, A is going to be 3 over 2, right? A can be a fraction or a number, but if it's a fraction, just move the 2 down here. So 3 over 2, or you can just write 1.5. Right, I'll write 1.5 to just clear things up, so it's not confusing. So 1.5 x minus 1 minus 2 y equals, of course. That's going to be your equation of this graph. Right? Okay, so this is going to be a square root function. As I said earlier, you have to consider either negative A or B values. So this is a normal root function. In order to get this shape, in order to get this function turning into this shape, you have to reflect it across the x-axis vertically, right? So it's a vertical reflection, meaning A is going to be negative. Okay. Once you establish A equals negative, we can either solve for A and B. So I'll just solve for B, and we can assume A is -1. Okay. So if A is -1, we also have H and K, which is 2 and 3, obviously, because that's the vertex where it starts. Okay, and then now you plug in 2 and 5 to solve for B. So that's going to be -1, 3. Okay, so it's going to be 1 square root 3b, 1 equals 3b, and b equals 1 over 3. So finally we get y equals negative square root 1 over 3 x minus 2 plus 3. That's your final equation. Okay, so I hope you guys enjoyed, and please leave us any comments, concerns, questions in the comment section.